This video is on section 4.7 from the notes, arc length. And what I want you to notice is this is essentially the three-dimensional version of the arc length formula that you learned in Calculus 2. So if we have our vector valued function r of t defined in terms of these three functions, this is essentially a three-dimensional parametric function. It's a vector valued function, and it has components, so the range values are vectors and not points in R2 like they were in Calculus 2, but the concept, the principle is very similar. So we can just basically think of this as a three-dimensional function similar to what you learned in Calc 2. And so this arc length formula, you have the derivative of the first component plus the derivative of the second component plus the derivative of the third component, all of those squared. So you have the sum of these squareds under the square root. What you had in Calc 2, you only had two functions, right? You would have had an x of t and a y of t. And so this is a three-dimensional version of what you learned in Calc 2. And if you look at this, though, what do we have? This is really the dot product of the derivative with itself under the square root. So that's really just the magnitude of the derivative of r. So we take that and we integrate that with respect to q. So we integrate from a to t, where this function, it starts at a. So t starts at a right here. And so we want the arc length. We're going to integrate from our starting point to wherever we are, where our parameter is. We integrate with respect to q. Now, what did we learn? This is actually a real valued function, right? We substitute, we put t into s, and we have this integral. And we've defined this real valued function in terms of an integral. What did we learn in Calc 1? What did the fundamental theorem of Calculus Part 1 tell us? That the derivative of s then is just this function that we're integrating. So we have the magnitude of the derivative of r. That is the derivative of s, because s is actually just a real valued function. Okay, so this is from Calc 1. So here's an example. We have the function, vector valued function f of t is cosine of t, sine of t, square root of 3t. We want to parameterize this curve with respect to arc length. So what do? First of all, we calculate the arc length in terms of t. So the derivative of f is negative sine t, cosine t, square root of 3. So we integrate the magnitude of the derivative. So we integrate from 0 to t, magnitude of the derivative evaluated at q, dq. Sine squared plus cosine squared plus 3. So this is just a square root of 4 right here. Square root of 4 is 2. So we just integrate from 0 to t of 2 dq. I skipped a step there to save space, but what's the antiderivative of 2 with respect to q? It's just 2q. So we have 2q, substitute t, substitute 0, subtract, we just have 2t. So s is equal to 2t. That means t is equal to 1/2 s. And so we'll define a function g of s. What is this going to be? This is going to be f of 1/2 s. F of 1/2 s is just cosine of 1/2 s, sine of 1/2 s, square root of 3 divided by 2s. So we just simply substitute 1/2 s in for t. 1/2 s is equal to t. So we have parameterized our curve with respect to arc length. So think about what this means. This t, this represents where we are on the curve with respect to our parameter t. This represents where we are on the curve with respect to the arc length.